Imagine a mid-sized city gets hit by flooding. Not catastrophic, not front page of every newspaper flooding. The kind that happens a few times a decade in a lot of places. Roads get cut off, a few neighborhoods are isolated, emergency response needs to move fast. The response team pulls up aerial imagery. And here's the thing. That imagery wasn't captured by a satellite that happened to pass overhead during the event. It wasn't shot by a news helicopter. It was built from a mosaic of drone missions flown in that city over the previous 6 months. Standardized passes, regular cadence, every hexagonal grid tile mapped and time-stamped. That data wasn't collected for this emergency. It was collected to exist, to be there when someone needed it. That's the shift I want to talk about today. Not the drones, not the network, the stuff downstream of all that. What actually happens to the data on a network like the LayerDrone network once it exists? And why the value of collecting it wasn't obvious until the moment you needed it most. Welcome to the Drone Network, the only podcast in the air and on the airwaves. I'm your host, Bryce, and on this show, we document the tech, economics, and people piloting the world's largest standardized drone imagery network. Each episode, we explore how drones are reshaping industries, creating new economic opportunities, and literally changing how we see the world. On today's episode, the data you didn't know you needed, and what actually happens when you upgrade the world map. Let's get into it. We're going to start with insurance because that's the industry where the value of fresh spatial data is most concrete and probably most underappreciated. Here's how property insurance works today at a high level. An insurer wants to know the risk, the profile of a property, rooftop condition, proximity to floodplains, vegetation overgrowth, structural condition. Use a combination of historical claims data, publicly available satellite imagery, periodic third-party inspection reports, and actuarial models built on all of the above. Every one of these inputs has a staleness problem. Historical claims data is, by definition, backwards looking. Satellite imagery in most markets updates on a scale of months to years. Third-party inspections are expensive, and they happen infrequently. The model tells you what the risk probably is, based on what things probably looked like some indeterminate time ago. Now, let's add high-resolution, time-stamped, standardized aerial drone imagery that updates on a rolling basis. Suddenly, the rooftop you're insuring isn't assessed from a satellite pass that may be 2 years old. It's assessed from a drone mission flown weeks ago. The vegetation encroaching on that structure is visible. The section of flashing that's starting to fail is visible. The new outbuilding the owner added without a permit is visible. Precision cuts both ways. It's not just that fraud gets harder, it does. It's that legitimate risk gets priced more accurately. A well-maintained property in a lower risk configuration can get priced accordingly, rather than being lumped into a generalized risk bucket, because the insurer didn't see it clearly enough to differentiate. I've talked about this in another episode, but there's a concept in insurance called the protection gap, the difference between insured losses and total economic losses after a major event. In the US, that gap has been widening for years, particularly around climate-related events like wildfires and floods. Part of the reason the gap widens is mispricing. Insurers can't accurately assess risk. Either they overprice coverage in areas they're uncertain about, driving people to go uninsured, or they underprice and get hit by losses because they didn't model correctly. Better spatial data doesn't close the protection gap by itself, but it's a meaningful input into closing it. If you can see what you're insuring, you can price it more accurately. If you can price it more accurately, you can offer it more affordably to more people. I don't think the drone industry talks about this enough, not because it isn't happening, but because it's not flashy. It's not cool autonomous drone delivery or explosive military applications. It's boring, necessary infrastructure. And I think a lot of what this episode is going to be is me arguing that that boring, necessary infrastructure is where the real action is. Let me take you to a different kind of equally exciting customer. municipal governments, because cities have a spatial data problem that is, in some ways, worse than insurance's. Every city has maps of itself: road networks, utility routes, property boundaries, zoning designations. These maps are the operating system that cities run on. Permitting decisions, infrastructure investments, emergency planning, all of it depends on having accurate spatial records. The problem is that cities change faster than their maps do. A new building goes up. The map doesn't know yet. A road gets rerouted. The city's GIS layer takes a while to catch up. A stormwater drain gets extended. Nobody logged it in the system because it was a small project and there's a backlog. Over decades, the gap between what the map says and what actually exists accumulates, and it becomes something significant. Traditional survey methods are expensive enough that cities can only commission them for specific projects. You might get a comprehensive aerial survey of a major corridor when there's a transit expansion underway. The neighborhood 3 blocks over, that wasn't part of that project. It's running on data from a survey that's over 8 years old now. Drone networks change the economics of this in a fundamental way. A mission covering a city block costs a fraction of what a conventional survey costs. Regular passes can be scheduled as a baseline service rather than a one-time project. And the data is standardized. That means it's comparable over time and across different areas. It's not just a collection of one-off snapshots with inconsistent resolution, metadata, and other factors. Mason Paul, Spexy's geospatial data lead and a previous guest on the show, mentioned something that really stuck with me here. He talked about digital twins, and let's unpack that term because it sounds technical and futuristic, and it's, well, yes, but also no. A digital twin is just a 3D model of a real-world asset that can be updated to reflect changes in the physical asset over time. The twin updates when the reality updates. For a building, that might mean the structural model reflects modifications made during a renovation. For a bridge, it might mean the stress data from sensors is integrated with the geometric model, so engineers can see both the shape and condition in one view. For an entire city block, it might mean a navigatable 3D model that reflects what's actually there today, not just what was surveyed 3 years ago. Mason described clients using this for large-scale infrastructure projects, highways, bridges. The value's obvious there. But the same principle scales down to smaller applications. A municipality monitoring the condition of its stormwater network. A school district tracking the state of its facilities portfolio. A transit authority keeping its station models current. None of that requires exotic technology. What it requires is fresh data, consistently captured in a standardized format. And that's exactly what a drone network produces. Let's go back to that flooding scenario I opened with. Because there's a pre-disaster mapping point I really want to make explicit. The most valuable map in an emergency isn't the one captured during the event. It's the one captured before it. Because during a disaster, you can't fly missions in the affected area, weather conditions, airspace closures, the chaos of the response itself. What you have is what was there when the situation changed. This is the logic behind pre-positioning. Emergency management agencies pre-position supplies in locations where they think they might need them. Pre-disaster drone mapping is the spatial data equivalent. You collect baseline imagery of areas at risk before the risk materializes, so that when it does, responders have a reference frame to work from. What's changed? What are the access routes that are blocked? Which areas are affected that weren't visible on the static public maps? You can only answer these questions if you have something to compare to. Without the baseline, you're navigating blind. The Haiti example I mentioned in an earlier episode, drones delivering humanitarian aid to communities cut off after natural disasters, depends on this kind of mapping. You can't navigate supply routes to places if you don't have current data on them. And the aid gets there because someone built the map, and this is important, before it was needed. Before I close, let's zoom out. Because I think there's a frame here that's bigger than any specific application. We've spent the last 3 decades building a searchable internet, indexing the world's text and images, and making them queryable upon demand. Google is the canonical example, but the broader project is you take information that used to exist in isolated silos, you connect it, you make it findable. That's what drone networks are doing, and that's what LayerDrone specifically is doing. It's the spatial equivalent of that project. Take data about the physical world that used to only exist if someone had the budget and the logistics to go collect it, and make it baseline available, regularly updated, queryable. The data isn't the product. The ability to ask questions of it is the product. What does this property look like right now? What changed in this neighborhood over the last 6 months? Where is the fuel load in this forest, and how has it changed since last year's controlled burn? Those are the questions that couldn't be answered affordably before, and now, increasingly, they can be. Every mission flown on the LayerDrone network is a contribution to that queryable layer, and that's the economic story here. Pilots get paid, clients get data. But it's also something a bit larger. It's the project of making the physical world as legible as the digital one. Anyways, that's this episode. I've been Bryce Blade, and this is the Drone Network. Thank you so much for listening. Thanks for being a part of the Drone Network. Subscribe wherever fine podcasts are served to get a new episode every week. And remember to leave us a 5-star review on your podcast app of choice. It helps a lot. Today's show was sponsored by Spexy Geospatial and LayerDrone. Learn more about standardized drone imagery built for global scale at spexy.com, that's spexi.com, and layerdrone.org. Thanks again for listening.